Hi, everyone. My name is John Kennedy. I'm the head of product for Amazon Lumberyard and Open3D Engine. And this is Liv Erickson. She's one of my senior product managers on Open3D Engine. Today, we're going to talk about the first stable release of Open3D Engine that we've actually launched today. So really exciting. We're also going to talk about how 3D development is changing and what that means for the development of digital twins and what some are terming the metaverse. So that's going to be really fun. We also have a live demo and some demo videos of what we've done in the engine. And with that, I'm going to hand it over to Liv.
Great. Thank you, John. I want to start off with a question. When you think of a video game, what kind of game comes to mind? When maybe you're thinking of a classic 8-bit game like Pac-Man, which John beat me at yesterday. Maybe you think of a game like World of Warcraft, where you have a massive multiplayer online game, or a game like New World. Maybe it's a first-person shooter that you play with your friends, or an open-world sandbox game where you're really focused on building and creating content, like Minecraft. There's a lot of different types of content that can be described by the term video game, and all of them are correct. Games as a category of entertainment have evolved from what was once the domain of an arcade cabinet to something that's a huge world with thousands of other players. Today, as John mentioned, we're going to talk a little bit about games. But we're also going to talk about more than games. We're going to talk about the technologies that are used to create games. We're going to explore the way that video games are paving the way for innovation in a number of different types of non-gaming applications as well. And yes, we're going to talk a little bit about the metaverse. And it may or may not be what you've already been thinking of. But before we get into that, a little bit more about me. My name is Liv. As John mentioned, I'm a senior product manager here at AWS. I work on Open3D Engine, which is hopefully the topic that you're here to hear about today. And I'm really excited to deep dive into this. Before I was at AWS, I worked at Mozilla on a different open source 3D game engine called Mozilla Hubs. And before Mozilla, I was at a startup called High Fidelity, which is also building an open source 3D engine. So when I talk about the metaverse, I promise I'm giving you my honest opinion. So historically, as I've mentioned, 3D experiences have been smaller, self-contained, single-purpose entertainment apps. But over the past decade especially, games have really expanded out and become more complex experiences with their entire worlds, and in some cases, economies. One way to look at this shift in game trends is through the evolution of the creator base. Games have always been about the players, but increasingly, games are becoming an opportunity for creative expression. Custom maps and modding communities for games in the 80s and 90s really paved the way for user-generated content to not just extend games, but to really create new types of games in and of themselves. Modern games offer really visually complex detail, which requires high-fidelity asset creation and management pipelines that are, in the case of these games that support user-generated content, really enabling players to create dynamic experiences themselves. Enabling players to take a larger role in content creation allows studios to introduce new mechanisms to extend a game's life cycle. And it allows players to really own their narratives and identities in these games that they play. And when games introduce these capabilities to allow players to build and create and share their own content and worlds, they're really extending this game experience out to massive audiences that an individual studio may not meet on their own or reach on their own. The cycle of iteration in games has shifted a greater number of games towards more of a platform model with these dynamic worlds that necessitate regular updates to the source code of the game, the engine, and a more iterative development model overall, increasingly requiring live operations and really interesting live experiences that are happening on an ongoing basis. We can take a look at some of this in action in a game like New World. Amazon Games launched New World, a massively multiplayer online game, back in September. And since launch, New World's hosted over 900,000 players. New World was built using the Amazon Lumberyard engine, which you'll hear a little bit more about on our journey to Open3D Engine. And it contains a lot of traditional elements of an MMO, things like an open world, player versus player and player versus environment combat, questing and crafting. But it also includes deep integrations with player-driven content both in and out of the game. New World features dynamic world states through faction conquest models and player customization opportunities through custom housing. This really encourages players to invest in building out their digital residency. Outside of the game, New World also has deep integrations with platforms like Twitch, which allows content creators and streamers to take a larger role in the game's overall experience. But the technologies that facilitate the development games like New World, which are in some ways quite literally new virtual worlds, aren't limited to the video game industry. Increasingly, we're seeing these technologies used in other areas of computing. It's no surprise that we found these metaphors from gaming intersecting with more traditional forms of computing, because video games have always been really uniquely suited to combine software and human experiences. They allow players to do a task in a productive way. Of course, that's not the most fun way of describing video games, but it really allows us to start looking at traditional computing in the world around us and building solutions that bridge the digital and physical worlds in a different light. It's impossible to look around at today's digital landscape and not see their influence in how we're thinking about computing, especially spatial computing. Let's take a look at some of these concepts and how interactive experiences that are building upon game technologies are starting to make their way into non-gaming experiences. In recent years, our basic unit of compute has gotten a lot smaller. With edge compute capabilities, the Internet of Things, more widespread network availability, increased bandwidth for that network connectivity, and the power of the cloud, our industry has seen a renaissance of spatial technologies. These capabilities give us the opportunity to collect data locally, anywhere, process that on device or in the cloud at real-time or near real-time speeds, and then do something to transform that data. And when we transform that data into new, immersive, interactive, and intuitive forms, what we're doing is we're unlocking new capabilities in the way we use and interact with data in the world around us. IoT sensors give us the ability to monitor mission-critical systems remotely. 3D simulation technologies, like the ones that are used to render video game worlds, can transform that data that's being collected in the physical world into a one-to-one virtualization, creating a digital twin. And once we have these digital twins, we open up the opportunity to utilize additional new technologies, like robotics and machine learning, to simulate an infinite number of scenarios, whether that's for training or controlling an actual robot at a location that you're not physically present in. Augmented reality technologies and the ability to draw digitally on top of our physical environment in a spatially aware way gives us new superpowers, essentially, and more context to interact with the world around us than we've ever had before, where virtual reality devices can actually transport a digital version of ourselves into an entirely different location. Consider how a shipping warehouse, like what you might find in an Amazon fulfillment center, could use 3D technologies to simulate packaging systems before ever having to build a physical manufacturing line. Or how a company like SimScale could provide simulations to customers before they start physical product development. The ability to take a 3D simulation and look at it and experience it in a one-to-one manner before ever building it allows teams to more effectively design, plan, and save resources and time at the stage where they're building products. And this use case of using the digital world to prepare for something that's happening in the physical one is just one example. As edge devices are more widely deployed, the potential for integrating the digital and physical worlds expands. And we'll talk more about that. Another area where we see the realized potential of spatial computing out in the world and utilizing this data that's being collected is in autonomous vehicles. Autonomous vehicles process real-time environmental data through sensors and LiDAR cameras and are constantly capturing and understanding the physical world around us. Sometimes these sensors are computing massive amounts of data, like millions of points of data per second, and then it's then transformed into a simulation so that engineers can make decisions about how to train vehicles to navigate safely in an environment that isn't always going to be predictable. And this ubiquitous computing model opens up a massive amount of opportunity in creating scaled applications to connect the digital and physical worlds with people in them. In other words, the metaverse is nigh. Now, there's been a lot of talk about the metaverse lately. It's not a new concept, but one of the reasons it's getting a lot of attention these days is that the technology is catching up to the promise. The largest game engine company in the world has raised $1 billion in investment for long-term plans to create metaverses this year. The biggest social media company in the world has declared themselves the metaverse company. We've seen statements from some of the largest technology providers talking about building enterprise metaverse experiences that utilize mixed reality headsets to interact with the world around us. Consumer hardware companies are releasing mobile phone-based augmented reality capabilities to hundreds of consumer apps, including games that you might play, but also for tools like figuring out where a piece of furniture might fit in your apartment. But before we go too deep into the rabbit hole of the metaverse, and we will go a little bit deeper, let's talk a little bit about what the metaverse is by first starting with what the metaverse isn't. Now, I love science fiction as much as anyone, but there's a few things I think it gets wrong about the metaverse. I want to be clear that when we're talking about the metaverse, I'm not referring to a vision of like one singular representation of the world that everyone has to exist inside of and live and work and play, owned by one company, and most of the time in these stories, everyone's suffering. I don't think that it has to be that way. I like to think that we can have a more hopeful vision for the metaverse. My definition of metaverse is relatively straightforward, and it leaves a lot of room for individuals and companies and organizations to put their own spin on it. When I talk about the metaverse, I'm talking about, quite simply, large-scale connected 3D applications that vary in purpose, whether that's entertainment or education or business, and everything in between. There's shared data and content and users, a lot of them, usually, that changes, often. It changes in response to a user taking an action, or something happening in the physical world, or a simulated event. The dynamic element is really key, and it's only possible when it's provided by a wide range of creators and content authors. And that vision really leads into collaboration, which necessitates an open metaverse. And to talk more about what we mean when we talk about an open metaverse, I'm going to hand it over to John.
Thanks, Liv. So, unlocking the open metaverse. This is really the why of why open source software, why Open 3D Engine. So I'm going to talk about the critical components for a metaverse, and then how we build them. There we go. So the first essential component of a metaverse is a persistent world. That means a world in which environments, objects, characters, and histories persist. So an event happens, and that persists, and that effect persists in the world. And then there's concurrent users. You've got to be able to have a world where hundreds or thousands of people can be in the same space with avatars interacting in real time, and having those be a single coherent space where everyone's seeing the same thing. And then there's live experiences. If you're born in the 80s or 90s, you probably watched a television show that was on a cycle, and you watched at the same time as all of your peers. And so you would talk about that episode of that show at school, or wherever you were in the workplace. If you were born in the 2000s or later, you're going to be talking about the shared virtual experiences you had. In fact, there's a really great example of one recently. Fortnite hosted a concert in Fortnite, with a singer, and everyone was there live experiencing the same thing at the same time. And people will talk about that and have that shared experience. And then there's economies. And this one's a little bit more controversial as a critical component, but we're seeing more and more virtual economies being essential to spur activity within the metaverse. So, terms like play to earn used to be a dirty word. It used to be associated with gold farming, which was which game companies tried to eliminate, actually. People in other countries grinding for items and then selling them and making about $100 to $200 a month, as a way for players who wanted to buy those items to bypass the grind, to save time. But now we're actually seeing legitimate play-to-earn models emerge, where players are creating experiences for other players. And that could be in-game. It could be them doing natural things in-game that the game maker sets up, or it could be that they're streamers who are streaming their own gameplay and commenting on that. There's such a rich field of people now engaging in and creating value in metaverses, in virtual worlds, that an in-game economy, or even an economy that spans many metaverses, is becoming more and more essential. And then there's a range of components that magnify the effect of a metaverse and the engagement and bring people to it. And some of those include real-time synchronicity. And this is the idea, really easy example is in a digital twin where I have a factory. I want real-time data sources streamed in from that factory so I can see temperature settings on a piece of equipment or a dial, or a real-time video streamed in so I can see the virtual world. I've got the visual context of where I am. I can also see the real-time data. Additionally, in game worlds, games like Pokemon Go need real-world data to be able to come into that setting. And so real-world synchronicity really enhances virtual worlds. And then there's interoperability. If you can take objects from one world to another, if you can take your identity, that magnifies the amount of content that's possible across all worlds. It means create once and use everywhere. It means my identity, my whole identity, can be brought wherever I go, into every metaverse that I go into. And then, as Liv was talking about before, user-generated content. More and more, we're seeing not just developers build, but non-technical people, artists, are able to create their own content that can go into worlds, and that's creating an explosion of content. We're seeing early versions of that in games like Roblox and Minecraft, but there are many more to come where the majority of content will actually be user-generated content. So how do we create these? Like, this is the how. We've talked about what we need, the components that we need. Now let's talk about the how. Just the storage requirements for persistent worlds will grow exponentially in the next 5 to 10 years. Already, we're seeing open world games with 30 to 60 gigabytes of data in them that you have to download, but that's baked data. In development, we see 10x to 100x of that to create those assets. There's a huge amount of storage required for virtual worlds, and we're even seeing baked games now up at the terabyte level in terms of the data, to the point where gamers or users need to stream the world in real time to save on initial download times and local storage space requirements. They actually need to stream the games in. They're that large. So huge storage is required. In addition, if you want to have a huge number of users in a space, if you want hundreds or thousands of users in a space, you need network and compute infrastructure that allows you to compute the state of the world as all of those users are interacting with it, and replicate that state to all of those users through the network. And we can see that a good example of the limits that we've hit with the speed of light and network infrastructure is a game like EVE Online, where if it's a spacefaring game. If you had thousands of ships in the game in one area, the whole game would slow down. Well, we're starting to address these now. We actually have the scale of compute and network infrastructure to be able to have thousands of people and eventually millions of people in the same space, seeing that space updated in real time. That's really exciting. You also need a network client that runs locally on each machine, on any type of device, whether it be tablets or desktops or other types of platforms, to enable that replication of those worlds onto the local devices. And let's go back to the magnifiers. So, I was talking before about how you have user-generated content, these kinds of things. Open standards becomes essential if you want interoperability. You've got to be able to have standards, and I'll talk about these in a minute, that allow you to bring objects from one world to another. Decentralized sources of truth for things like identity become really important. I don't want my whole identity to be just stored by one social media network. That's a bad plan. So decentralized sources of truth become really important. And then spatial data. Just a few, was it months or weeks ago, very recently, Cesium came out with the whole city of San Francisco in Open 3D Engine, down to the millimeter. They've got the buildings mapped in that 3D space. This is amazing spatial data, so you can create real-world experiences. I think we were talking the other day about how you might learn to navigate a city in a virtual city, because that virtual city is so accurate. And then having all of the other spatial data brought into virtual worlds really magnifies their relatability to people navigating them. And then open source software. I'm going to go into that a little bit more soon. So let's talk about the levels of interoperability. Right now, we have a lot of single client metaverses. Let's talk about Fortnite. There's ways to bring in content into Fortnite, but it's one single proprietary client. So really easy content creation, but it's central control. And that doesn't leave a lot of room for interoperability with other platforms. The next level up from that is web client. So here, you've got one open client, so you can potentially access different worlds with that web client. Great example of that is Mozilla Hubs that Liv previously built, and it means you can have a lot of different metaverses, but there are still issues with this single client approach. Access to the hardware is still an issue. There are better 3D libraries for web browsers now, but we're still not seeing the performance of even individual clients, of custom clients, and that's really where we're going. We're going to a multi-client shared standard interoperability where you can create custom clients for custom use cases, but you still have that interoperability. They'll be highly customizable, and these clients will be persistent and build on their own innovation, and a lot of them will be decentralized and will be open source. And this is really the best kind of interoperability we can have. A great example of this, of a shared standard recently, is a universal scene descriptor, which describes objects. You can use that in many, many different digital content creation tools now. Another one is MaterialX for materials, so we're starting to see it happen. So let's talk about where an engine sits in this, what the value of an engine, and specifically the Open3D engine is for building virtual worlds and metaverses. Engines are really actually three things, or most engines, most 3D engines. They are a library of capabilities like physics and rendering that developers can use. They're also an editor, so a content creator can go in and see that virtual world before it's been compiled and navigate around it and create objects and art in that world. They're also a client, like we were talking about before, the scalable network client, the client that you want that's interoperable. They're the start of that client, so you can deploy it across many different platforms. And we see a number of components common across 3D engines. So these core components are really what we've thought about in Open3D engines. So the asset importer, the ability to bring in assets in standard formats like FBX or even CAD files, service integrations if I want to use external services for that data that we're talking about, the spatial data, other data we want to bring in, real-time data sources, the 3D renderer, so I can actually have really interesting render effects in a virtual world. I can create particle effects and these kinds of things and build on the type of renders I can do. And then the physics engine. This is not required necessarily for digital twins, but physics becomes really important in a lot of situations where you want to see collisions or you want to see movement in the world and simulate the real world. And then the editor. The editor allows someone to open up an application, we'll see Liv do that pretty soon, and actually edit that 3D world. And then the animation tool. If I want to be able to take a character and rig it and create animations for it that can be triggered on certain events, then I need a whole animation editor. And a no-code scripting tool. In Open3D Engine, we call this Script Canvas. In Unreal, they have Blueprint. There's one for Unity as well. This is really common. You don't want your developers to be doing all of the behavioral scripting. You want to be able to have an event system where on an event, something can happen in the world, and you can create that in a no-code tool where it's a node-based experience. And then cross-platform compilation. So I want the ability to compile for iOS, Android, PC, Mac, Linux, and Open3D Engine can compile for all of these. And we have support for consoles and XR coming, which is what Liv will talk about soon. So Open3D Engine really contains all of these elements that allow you to build virtual worlds. And the fact that it's open source means that we're building open source standards. We're building interoperability. Everyone has access to the Open3D engine under the Apache 2 license. All of that content is reusable and persistent because everyone will always be able to access it by virtue of that license. These are shared tools that we've got within the engine for user-generated content that people will be able to extend if there are specific use cases to make it easier for users to create their content. In the past, and in fact, we know that about 74 of the top 150 gaming companies have their own private engines. It took hundreds of people to build an engine if you wanted your own custom engine. Now, with Open3D Engine, even small teams will be able to create their own engine and build on top of Open3D Engine, own their whole stack, because it's Apache 2 license. They really get to own their whole own stack, their whole own software stack. We're creating standards for spatial. By having an open source engine and having great adoption, standards for spatial will be inherent. We're going to create more standards in the world, and we're doing that for certain parts of the engine at the moment that we expect other digital content creation tools to use. We're also going to accelerate XR and simulation and digital twins. In fact, next year, and Liv's going to talk about this a little later, we're going to have a digital twin release where we're going to release more tools for people creating digital twins. And then finally, open source communities, by nature of having a diverse and broad community, naturally bring greater accessibility to projects. I've seen this in many of the open source projects that I've worked on, certainly that ability to create greater accessibility. So some of the transformations we've seen in other industries have been really stark. If you looked at the end of the 2000s at the open source, at operating systems, when Linux was coming to the fore, the end of the 90s, Linux emerged as a project from Linux, but then it became a global revolution of operating systems, and now 99% of web workloads run on Linux. By the fact that Linux exists meant that we could create a cloud that focuses on operational excellence and scalability, and for customers. If Linux didn't exist, the licenses of other operating systems would have really stopped a lot of that innovation. And in content management systems at the beginning of the 2000s, there were some big proprietary content management systems, and then a range of digital agencies almost all large digital agencies had their own content management systems, similar to what we're seeing now with all of those large game companies having their own game engines. Well, in the early 2000s, Drupal and WordPress emerged, and then millions of sites were built on these open source content management systems. And all of those digital agencies, or the vast majority of them, moved over onto open source content management systems. With that base, those shared table stakes of functionality that were in those content management systems, they were able to build beyond that, build innovation on top of that. And this is the trend that we see is of shared table stakes in open source software with a small core of core functionality like I was talking about before, those core elements of the engine, and then people building functionality on top of that in form of modules. In Open3D Engine, we call these gems, and that means you can have faster release cycles for this edge functionality because you're not beholden to the core release cycle. You can release in months instead of once every 6 months. So this really spurs innovation in open source projects. We're also seeing it in search with Elasticsearch and now OpenSearch from AWS. And another trend we see in open source is users become contributors. People scratch their own itch. They go out and they use the engine, and then they see just that extra 10% of functionality they want. They build it, they contribute it because they want the community to help them support that functionality, and then we gain speed. It's a virtuous cycle or a flywheel of functionality. So how do we get here? I'm going to talk a little bit about Lumberyard and our history of getting here. So, we put a lot of effort into Lumberyard. Back in 2015 and earlier, we bought a license to the Cry engine, a perpetual license, and we've built on top of that. Over the past 5 years, we've released 28 versions of Lumberyard. We've done a lot of third-party integrations for game companies to be able to integrate with a range of functionalities externally, and then a range of integrations to make Lumberyard a cloud-first engine to be able to access all of the AWS tools and all of the tools externally. We also replaced the physics engine, number of internal systems. This is millions of lines of code, a huge project. And we had a lot of success out of that. We've got New World, which obviously is huge and incredibly successful. There are a number of other games that we released internally, and other games publishers that have used the engine, like Wargaming and Carbonated and Star Citizen, et cetera, that have used the engine to build. So we took Lumberyard and then we brought together, we knew that to get greater adoption, the best thing for the engine would be to go completely open source. Lumberyard itself was on a source available license. The Open3D engine, we decided to form a foundation and actually put it under the Apache 2 license, so that we had 26 partners. I'm going to rattle them all off here. It's going to take me a second, but we had Accelerbyte, Adobe, ourselves, Apocalypse Studios, Audiokinetic, Backtrace, Carbonated, Futureware, GamePoc, Genvid Technologies, Hadean, Here Technologies, Huawei, IGDA, Intel, Kitbash 3D, Kythera, Niantic, Open Robotics, Popcorn Effects, Red Hat, the Rochester Institute of Technology, RIT, Side Effects, Taffy, TLM Partners, and Wargaming all come into this one foundation to launch the Open3D engine. And we did. We launched the developer preview in July for developers to actually to try it out, to evaluate it. And we had amazing engagement. On GitHub, we've got 3,700 stars, we've got 1,200 forks, we've got 4,700 pull requests, 2,500 issues. This is really great engagement over that period of time for an open source project. And I worked in open source for 10 years before I came into AWS, and this is the largest project and the best engagement I've ever seen. And certainly the Linux Foundation, who partnered with us to build this, say this is their fastest growing project. They're with the best engagement they've seen in many, many years. So over 310 contributors and many people on our Discord. I encourage you to join. And then a number of great statements we've had coming out from our partners and community members. If you want to check out some of those, some of the things that people are saying, you can check out the press release or come onto our Discord or forums or other places. So now I'm going to hand over to Liv to really dive into the details of the Open3D engine.
Thanks, John. So as John mentioned, back in July, we launched the Open3D Foundation and released the developer preview of O3DE. At its core, what we wanted to do with the developer preview was give contributors and partners access to the engine in a really early state to really give them ownership and influence over the direction of the project. So from the ground up, Open3D Engine has been designed to give developers and creators control over every element of the engine. John talked a little bit to that earlier about the different pieces of a game engine, and Open3D Engine was designed so that you could take those subsystems and customize it to the exact need that you have. At its core, Open3D Engine, at the core of Open3D Engine is Atom, which is a new multi-threaded forward plus photorealistic renderer. I am not a rendering expert, but what I can say is it makes very pretty environments, some of which you'll see later, most of which were not made by me. There's also a low latency networking transport layer included in Open3D Engine. John mentioned the physics engine that's there. We have high-performance math libraries that we've updated, cloud integrations for multiplayer authentication, and the ability to provision AWS services from directly in Engine. We've got the visual scripting tool, which you'll see in a couple of minutes when I jump over into the live demo, and new JSON-based game object template systems that can be scripted so that developers can build custom tools for their team's asset pipelines. You heard a lot about asset pipelines in the user-generated content and the importance of this, and giving creators the ability to extend and build upon that is key. So today's release of the Open3D Engine, we went live this morning with the first stable version of Open3D Engine, version 21.11. Makes it easier for teams and developers to get started with O3DE quickly. We have a new Windows installer and project configuration workflow so that instead of having to build the engine from source, as it was released in the developer preview, teams can just grab the installer from online and get started right away. We also have a new Linux support for the engine, which was one of the most top requested features when we published our proposed feature development roadmap to the community back in July, which means that teams can work on a fully open source stack, both for editing, but also for creating games that run on Linux. We have new tools for content creators and authors as well, including a new experimental terrain gem to build environments in O3DE. We've surfaced the networking capabilities in that low latency networking stack to Script Canvas. We've added functionality to the renderer, like in-editor color grading. We've started also adding performance benchmarking capabilities because as we reach more devices for Open3D Engine as publishing targets, it's important that developers and teams have the ability to profile their experiences to understand how they're running and optimize them. And we've also introduced the ability to manage gem repositories and access gems remotely. As teams are making the decision to adopt Open3D Engine today, they're doing so with the support of the open source community. So that includes Open3D Foundation partners, including us here at AWS. But because we're open source, they can also choose to take active participation or even leadership role in the community and in the direction that the engine takes. But I think it's a little bit more fun if we jump into it. So let's go ahead and dive into the live demo here. I want to give you a disclaimer before we get started. I am a product manager. I'm not a technical artist. I am not a game designer, and that will probably become evident in just a second. So over here, we've got the 21.11 version of Open3D Engine, and we've got a live demo for you. I am a product manager, so I could build anything that I wanted with the metaverse technology that is in front of you. So I built a presentation tool. But it's not your typical presentation tool. It's a little bit more fun, I think. you can see over here, we've got some adventurous astronauts and some different slides over here. You can see examples of the physically based rendering over here in the shader ball from the Atom renderer, but this is not going to be the prettiest demo that you see today, don't worry. But over here you can see this all in the editor. I think we should make a couple of changes. I first want to say I feel kind of bad for this cow. I think I'd be getting sick. I know astronauts get training, but this is a little bit too fast. So let's jump over here out of game mode into the editor itself and start taking a look at how we might be able to make this poor space cow a little more comfortable. So this space cow is a prefab, which is one of I mentioned the JSON templating system. We call them prefabs. It's JSON-based, so you can write scripts that can edit the JSON files or open them up, and it's a human-readable format. But what this allows us to do is create templates for entities in the scene. In the 2111 release of O3DE, we've made some changes to how you can edit prefabs. So I'm going to go ahead and enter the edit mode for our space cow over here. And I'm going to select this entity and go ahead and take a look at the script canvas here. We've got our script canvas editor open, so I'm just going to open up the script in the visual scripting tool. And you can see it only takes 5 nodes to make this poor cow sick. So what we'll go ahead and do here, this is controlling all of the cow's movement. I'm going to jump over to where I'm increasing the rotation speed, and I'm just going to slow this down a little bit here. And I can go ahead, save the script canvas, go ahead and minimize script canvas over here. And then when I jump back into play mode, you can go ahead and take a look, and that looks a lot better. I think the cow is probably a lot more comfortable. You know that this is a live demo at this point, so I can probably just go ahead and take this slide away. We'll just hide that for now. But this is kind of a weird environment for an astronaut cow to be flying around in, so maybe we make it a little bit more space-like. Right now I'm using the default environment that comes with the Atom renderer, and it is beautiful, but it's not very space-like. So let's go ahead and take a look at the skybox that we have here, and I'm just going to go ahead and drop in a new cube map for it. Much better. Now we've got some stars, we've got a pretty solar system. You can see that it's pretty quick to just play around with different environments, and the environment of an experience will make a big difference on the way it feels and how well the flying space cow goes with it. But I think with that said, we can take a look in here. We can look in play mode again and see how it's looking. We can see our metaverse sign is reminding us that we're walking into the future. And it looks a little lonely. So I think what we'll do now is we'll add a couple more space cows. So I'm just going to go ahead and duplicate our space cow prefab here. I'm going to pull it over so they're not overlapping each other. And because they're prefabs, I don't have to go in and recustomize all of the different prefabs that we have here. I just have multiple space cows. And now we've got some synchronized astronaut cows floating around in space, because this is what the metaverse was really meant for, right? So you can see here, these are just a few of the editing tools, a very small number of them, and the features that we've added to and worked on in the 2111 release. One of the big things that we do as part of an open source community is focus on the usability of the engine. And we've developed a program that we run through our user experience special interest group, which is one of many that community members can participate in to direct the future of the engine, through a program called Rev the Engine, where we are continually running iterative user tests and testing out the different user workflows. And so a lot of what you see here today and some of these improvements to the content authoring tools are early as part of that program, but it is one that if you're interested in participating in, you have available to you if you join the open source community that O3DE offers. So with that, I'm sure you're all questioning whether this is the most beautiful thing that can be built in the engine, and it's not, I promise. And so what we'll do is we'll go ahead and take a look at some of the things that other content creators who have been working with Open3D Engine have been building over the past several months. So we'll go ahead and we're going to start with a video by one of our Open3D Foundation partners, Apocalypse Studios, for the game technology demo that they're building for their upcoming game, Dead House Sonata, which is being built on Open3D Engine. This video demonstrates a number of different capabilities in the engine and is a highlight of the type of game that they're working on. You can see here that one of the things highlighted in this demo is the character animation system, both in the player-controlled character that you see here in combat in the center of the screen, who's being controlled by either a keyboard or a mouse or a controller, and in the artificial intelligence-based computer characters that the player is fighting. You can also see examples of the atom renderer in action here, as well as particle systems. You can see the dynamic lighting that's happening in the environment as the player is moving around and the lighting effects are changing. And you can see the particle systems that are responding to experiences happening. For example, the sword and shield connecting with one another is generating sparks, or if the enemy character collapses, there's some dust that's floating up from the ground. But games aren't the only thing. I mentioned the use of simulation technology for autonomous vehicles, but another area where 3D engines can be used in the automotive space is in concept rendering. You can also imagine this applied to things like an interactive configuration tool, where someone could customize the way that their vehicle looks and maybe even add a driving experience and drive it around. This demo reel was created by an internal team to show the use of physically based materials and lighting, and you can see here in this render. In a similar vein, Open3D Engine can also be used to render photorealistic interiors, which can enable pre-visualization of building designs in detail under different lighting conditions, maybe an indoor and an outdoor lighting scene, and you can see how the sun comes in a window and changes the way that the space feels. And you can import these assets for these types of renderings and simulations from different CAD tools. So when you're generating 3D experiences in other asset creation tools, you can bring them in and modify them in Open3D Engine with a number of these different authoring tools, some of which you got a preview of today. These are just a couple of small examples of what can be done with O3DE today, and we're really just getting started. There's also a number of demo games that you can find on GitHub with open source code as well, and assets that you can use to create content. So as I mentioned, we're in the early stages of Open3D Engine. Today's release is the first stable release, and we are really looking forward to the continued work with the community and other foundation partners. Here at AWS, we've got a couple of ideas that we have for Open3D Engine and plans that we'd like to contribute as we look ahead to 2022. As John mentioned a little bit earlier, we're planning a couple of focused, targeted releases, some for non-gaming applications and some for those creator-first studios who really want to focus on creative content and building out game experiences. Early on in 2022, we're going to start work for a number of features that'll help with teams that are building for digital twin experiences. So we're going to look at building out integrations with different IoT devices and other AWS services, including gems for things like AWS RoboMaker using the ROS2 open source standard. We're also going to take a look at building out support for virtual and augmented reality devices through the Khronos Group's OpenXR standard, which will allow developers to build virtual and augmented reality experiences with O3D. And I mentioned the extendable asset pipeline. This is a pretty key element for building digital twin experiences because this type of data and content comes from a lot of different places and is in a lot of different file types. So we'll continue our work on the asset pipeline for O3DE to make sure that developers have as much choice as possible in how they're bringing content into the engine. Later in the year, we'll look to the different creative studios and how we can provide tools that will help them with pipelines for things like animating characters. You saw some of the examples of this in the Apocalypse Studios video today, but there are a lot of other advancements that we can do in the animation space, including things like full body inverse kinematics so that you have more range of motion as you're moving around, or even things like representing a physical body with someone who's wearing a sensor suit. You know, we have a lot of different potential for how people are bringing in movement, and we want to start to explore the different ways that we can improve animation tools for that in O3DE. We also want to look at building out more features around terrain authoring and weather systems in the engine. to give creators more control over building environments. And we want to look at building visual shader technologies so that you don't have to write shader code in the engine in order to create dynamic experiences. Because this is an open source project, the way that we operate is we produce request for comment documents that we publish to the community on GitHub, and that's how we determine whether or not a feature that we're proposing or something that we're thinking about is work that our team should take on. So while these are the things that we're thinking about for 2022, there's a lot of ways that the community's feedback and the special interest groups will help us make decisions about what will go into the engine and when. If you want to see any of these things especially, it's a great time to weigh in. So to get started, I mentioned, as of today, you can download a Windows installer and an Ubuntu package for Open3D Engine for version 2111. Developers have a number of different choices to get started with O3DE, depending on the specific use case that you have and the needs that you have from the engine. You can just install the pre-built binaries to get started quickly, or you can grab the source code for O3DE on GitHub and completely customize the engine from the ground up from day one. And as I said earlier, as you begin to explore Open3D Engine and the 2111 release, we invite you to join the community to be a part of this larger open source initiative that's bringing the vision we set forward at the beginning of this talk to life. And with that, I think we'll go ahead and open it up for questions.
Anyone?
With the building of a digital twin, will it make it easier to create the environments? Like, I can just walk around with a camera in this room. Will anything with the engine help with creating that asset, right, of the room, taking these pictures?
Yeah, so I think we've been talking about our vision around digital twin for a long time now, what we really want to create. We're seeing some really interesting digital twins out in the world, like operational digital twins to help people manage operating environments, whether that be a factory or a gas plant or something like this, where operators need the visual context, of both the real-time data and the environment. So there's a lot of things you need to bring into that. We also think about design digital twins and training digital twins, but to focus on manufacturing for a second, the vision we have is the ability for someone who's non-technical to bring in the environment, bring in all of the objects, and then attach real-time data sources from AWS and be able to do that in a few hours. Right now, this takes developers months. If you look at other engines or the processes they use, we've gone around and talked to many customers in automotive and in manufacturing and in aerospace. They all are trying to do the same thing. They all want to get to 3D. They want to get to digital twins. It takes a lot of development. So our vision is to create tools in Editor, and this is what we'll be coming out with next year. And AWS doesn't share roadmaps, but lucky for us, we're open source, so we can actually share the open source roadmap. That's a goal of ours, is to bring those, the tools so you can bring in an object straight from cloud into the environment and set up an environment with drag and drop ease and attach real-time data sources from things like AWS IoT and Kinesis just with a drag and drop tool. Anyone else? OK. Let's skip to our last slide. If you want to contact us directly, you can see our email addresses there and Twitter handles. I hope you do. Please reach out. We would love to have conversations about what you would like to build in the engine or how you'd like to contribute, or even just questions about the engine. We'd love to hear it. So please reach out, and thanks for coming to our talk.
We'll see you in the metaverse, one of them.